Okay, so today we're going to cover the last part of section 4, and what we're going to do today is factor completely. What we're going to be doing is combining all of the factoring techniques that we've talked about, the factoring the GCF, the factoring the difference of two squares, the factoring of the sum and difference of cubes, the factoring by grouping, factoring of perfect square trinomials, and then the traditional factoring of the trinomials that we learned yesterday. So all we're going to be doing is combining all of these factoring techniques into one problem. Now you may not have all of them in one, but you will have more than one technique within each problem. So always look for a GCF first. That should always be your first step. After you do that, then you're going to look for either, if it's two terms, it'll be the difference of two squares, or the difference or sum of two cubes. If it's four terms, I would definitely look first for a GCF and then look to see if you can factor by grouping. When you see three terms, it's either going to be the perfect square trinomial or the traditional trinomials that we did yesterday. Now, if you're not good at recognizing perfect squares, you can still factor perfect square trinomials in the traditional way. It's just going to take you longer. So let's go ahead and just do a whole bunch of examples of factor completely. So the first one, always look for a greatest common factor. So I can see that the greatest common factor between 12x squared and 48, there's no variable in common, but they do have the factor of 12 in common. So I'm going to divide both of them by 12 first. I like to show the division. You don't need to do that, but you do need to remember to put that GCF out in front of what you're getting after you divide. So after I divide 12x squared by 12, I'm left with x squared, and then 48 divided by 12 is going to give me 4. Now what remains, I can still keep going. And this is the difference of two squares, because x squared and 4 are both perfect squares, and there's a subtraction sign in between. So this is the difference of two squares. Don't forget about your GCF, and then x squared minus 4 will factor into x plus 2 and x minus 2. If you would prefer to put the x minus 2 first and then the x plus 2, it doesn't matter the order. But do not forget to keep bringing down that GCF, because if you forget it in the final answer, chances are you're going to lose some points. The next one, number 2, always look for a greatest common factor. Notice both terms here have an x in common. So I'm going to divide both of them by an x. What remains is x squared minus 16. And again, I have the difference of two squares. I'm just going to go ahead and square root each one. And x squared, when I square root it, is x. Square root is 16. Is going to be positive 4 and negative 4. And I'm done. The next one, I highly recommend that you get into the habit of making your x squared term positive. When you did the web assign last night, you had to factor out the negative 1. So I'm going to first factor out a greatest common factor of negative 1 to make my x squared term positive. After I divide each by a negative 1, all of the signs change to opposite. Now what remains is a perfect square trinomial. So if you catch that, then you can just square root the 9x squared, and that gives you 3x. Square root the 1 gives you 1. And remember, double it and make sure it gives you the middle. And because it does, I can just use the trick now of factoring this perfect square trinomial. And each binomial is going to be the same. And if you don't want to write it twice, that's fine. But the square root of 9x squared is the 3x, goes in both spots. and then the square root of 1 is 1, and they're both same sign of the middle. So you could either write it like that, or whenever you factor a perfect square trinomial, what remains or what you get out of it is a binomial squared. So you could write your answer either way. Now, if you didn't catch that 9x squared and 1 were perfect squares, you could do it like we did yesterday, where you multiply the first and the last term. And we would be looking for factors of 9x squared that when I combine them give me negative 6x. So if you didn't catch that the first and the last term were perfect squares, you could have also done it the traditional way that we did yesterday. The next one, always, always, always look for a greatest common factor first. Now also notice this problem is not in standard form. So I recommend that you rearrange it first and put it in standard form. Standard form means to put the largest exponent first, all the way down to the constant. This one doesn't have a constant, so I'm just going to rewrite it as negative 3x to the third plus 9x squared plus 12x. Now I'm going to factor out my greatest common factor. And again, I want to try to keep that leading term positive, so I'm going to factor out a greatest common factor of negative 3. So once I divide, actually negative 3x is my GCF here. I'm going to divide all of them by negative 3x. After I divide, I'm left with x squared minus 3x minus 4. I now have a trinomial that can be still factored further. This is what we did yesterday. Now again, don't forget about that GCF. Make sure we keep bringing it down. So now what I'm looking for to factor what's in the parenthesis now, I'm looking for factors of negative 4. So two numbers that multiply to give me negative 4. Maybe I'll do it in, so two numbers to multiply to give me negative 4, but who will add to give me negative 3. So if I start my organized list, notice the signs need to be different in order to get a negative 4. And the larger factor is going to be the sign of the middle. So 1 times negative 4. And notice that will also, when I add them, give me the negative 3. So I don't have to go any further. So I'm going to go ahead and put those into my binomial. Don't forget about the GCF. And it becomes x minus 4 and x plus 1. If you would have preferred to put the x plus 1 first, that is fine as well. First glance, you may think, what is that thing? This is actually the difference of two squares. So what all I need to do is square root each one. So once I square root this, square rooting a square cancels it. So in my first spot of my binomial, I'm just putting x squared plus 8, because that's the square root of x squared plus 8 squared. Then I'm going to square root the 36x squared, and out of that is going to give me 6x. One gets a plus sign, one gets a minus. And now what I need to do is rearrange this so I can keep factoring. So I'm going to go ahead and put it in standard form. X squared plus 6x plus 8. X squared minus 6x plus 8. I've now produced two trinomials that I can keep factoring. So I'm doing what I did yesterday. So for the first one, I'm looking for two numbers that will multiply to give me 8, but who will add to give me 6. And my factors of positive 8 are going to be 1 times 8 and 2 times 4. This one, when I add them, gives me 9, but this one, when I add them, I get the 6. So my two factors that I need are 2 and 4. So then it ends up being x plus 2 and x plus 4. Now I also need to do the other trinomial, but notice my middle term is negative. So again, two numbers that are going to multiply to give me the positive 8, but who will add to give me negative 6. Notice when the last number is positive, the signs are the same, and they're both going to have the sign of the middle. So this will be negative 1. Let me do it in a darker color. Negative 1 times negative 8 gives you positive 8, but when you add them, it gives you negative 9. But then negative 2 times negative 4, that'll give you positive 8 when you multiply, and it'll give you the negative 6 we need when we add them. So negative 2 and negative 4 are my factors that both multiply and add to give me the appropriate numbers. So in here goes x minus 2 and x minus 4. My final answer are these 4 binomials. So what we had here from the beginning was the difference of two squares. So let me show you a simpler one. Let's say the original problem was x squared minus 9. When you do that, you square root the x squared, and then you would square root, here, let me do it in a darker color. So then when you have the difference of two squares, the red square root goes first, and in the problem up above, it was the green square root. And then the blue square root, which was the yellow up above, would go here, and then one gets a plus sign, one gets a minus. So that's what went in here. I square rooted this one, and that's what went here and here. Because when you have something, even if it's a binomial, anytime you square root something that is squared, it just cancels the square, and then the square root of that is just x squared plus 8. Whatever was under or being squared comes out. And that's what I wrote in green. And then the square root of the 36x squared, that gave you 6x and 6x. And then remember, one gets a plus sign, one gets a minus. And that was the same thing that I put here, plus and minus. And then you had to look to see, could you still factor it further? And I could have, because it turned into a trinomial. This one, the way this one was written, you can't do anything further. All right, so for the next one, notice there are 4 terms here. So this would be a clue that you're probably going to factor by grouping. I always would look to see, even if it's factor by grouping, if there is a greatest common factor that will come out of all 4 terms, but there's not. Now, you can either choose to leave it in this order or rearrange it. It doesn't matter. If it's able to be factored by grouping, it won't matter. I'm going to leave it alone, and I'm going to make my groups. So I'm going to make a green group and a yellow group. I'm looking for the greatest common factor of my green group, which is going to be x squared. I'm going to divide each of the terms by x squared, and what remains is going to be 3x plus 1. Then I'm going to look for my greatest common factor of my yellow group. Now, at first glance, you might think it's going to be a positive 9, but in order for what remains after you divide to be the same, I need to pull out a negative 9 GCF. After I divide negative 27x by negative 9, I get positive 3x, and then negative 9 divided by negative 9, anything divided by itself is 1. Notice what's in the parentheses is the same. You write that down, and then take the 2 GCFs that you found, that you divided by, and they go in the next parenthesis. Now, take a look at your binomials. If you notice that there is something that still could be factored further, we got to keep going. And the yellow one, the x squared minus 9, is the difference of 2 squares, so I can keep going. I'm just going to square root the x squared. So what it creates are two binomials. The square root of x squared is x, and then the square root of 9 gives me 3 and 3, and then one gets a plus sign, one gets a minus. Don't forget about the other binomial that you couldn't do anything else with. The order that you write those three binomials does not matter. You could write them in any order. And then the last one, I'm going to notice that I have a greatest common factor. Remember that your GCF doesn't have to be just a variable or just a number. It could also be a binomial. And my GCF here of this one is actually the 2x minus 1. So I'm going to divide both of my terms by this GCF. And then now what remains, put the GCF out front. And now after you divide, this cancels. You're left with 4x from the first one. And then over here, when you do this one, you're going to take one of the two x's away. And then you're left with positive 2x minus 1. Look for any like terms to combine. Write the GCF. I can combine these two, and it becomes 6x minus 1. And now I'm done.